Today we're going to be proving an interval when you multiply it by a number that is a real number. So we're going to do an example and I'm going to show you guys how to do this. So the interval we're going to be working with today is I is going to be equal to -2 to 3. The left side is going to be open, the right side is going to be closed. And what we want to prove is the interval -2i. So we want to prove -2i. So the way to do this is we're given an interval I and it's equal to this. So what this is saying is that I is a subset of this interval and this interval is also a subset of this. So what this is saying is -2 is a subset of I. So everything that's in this interval is also an I. And then it's also saying that I is a subset of -2 to 3. And then when you have subsets going both ways for an interval and the set I, they're actually equal. So because we have this and we want to prove -2i, we also have to show the same thing. We have to show that -2i is a subset of another interval, and we have to show that that interval that we find is also a subset of -2i. So this is a two-step proof. So I'm just going to start writing the first part of the proof and you should see how it goes. So we're going to write like this, proof. Whenever you want to show that -2i is a subset of another interval, you start with an element in -2i. I'm going to call that element y. So I'm going to say, let y be in -2i. Okay? What does this mean? This means that y equals -2x for some x in the interval I. Then y equals -2x for some x in the interval I. What's the interval I again? It's just this -2 to 3. We're saying that x is in I, so what does it mean for x to be in I? It means that x is in the interval -2 to 3, right? So it means that x is in -2 to 3, which we can say we're going to use inequalities now. So how can we represent x being in this interval as an inequality? Well, first of all, this is a round bracket, so x can never equal -2. So I'm going to say -2 is less than, not equal to, because it's the round bracket, x, and because we have 3 as our right endpoint, and it's a closed bracket, we're going to say less than or equal to 3. Okay? Now, we're going to manipulate this inequality. How are we going to manipulate this inequality? We're going to multiply it by -2, and you're going to see why. Multiplying by -2 results, when we multiply this inequality by a negative number, it switches everything. So when this -2 is being multiplied by -2, it actually becomes to the right side. And then same thing with this 3, it's on the right side. So when I multiply by a negative number, it switches around. So when I multiply by -2, I get -6 is, we still have less than or equal to, because the -6 came from the 3, but we're multiplying by -2. So we have less than or equal to x. Oh, not x, it's -2x now, because we're multiplying everything by -2. And then we have this is less than, we're talking about the left side being multiplied by -2 now, which brings it to the right side. -2 multiplied by -2 is going to be 4. So this is the inequality we have now. -6 is less than or equal to -2x, which is less than 4. However, we said that -2x is equal to y, so we're going to substitute this in. So -6 is less than or equal to y, which is less than 4. So this is the exact inequality that we want, because this is saying that y is in the interval minus 6 to 4. Thus, y is in the interval, close bracket, minus 6, because we have less than or equal to. The equal to makes it a close bracket. And then we have 4, which is an open bracket because we have a open 4 here. So what is this saying? We have proven something here. This is the first part of our proof. So we went from saying y is in minus 2i, and then we found that y is in the interval minus 6 to 4. So hence, minus 2i is a subset of minus 6 to 4. So this kind of tells us our answer now. We can expect that minus 2i is going to be equal to this interval minus 6 to 4. However, we still have to prove the other way, starting with an arbitrary element y to be in the interval minus 6 to 4, and then showing that it's actually in minus 2i. So that's the next part. Let's go do it. Okay, I just erased everything so I have more room. Don't erase it on your work, but we're going to start with the second part of the proof now. So now what we're trying to show, we already showed that minus 2i is a subset of the interval minus 6 to 4. Now the second part is showing that minus 6 to 4 is a subset of minus 2i. And then once we have that, we can say that the minus 2i set and the minus 6 to 4 are actually equal. And then that's our answer. That's our claim. What we say is, now let the arbitrary element y be in the set or interval minus 6 to 4. And then this means, same as before, we're going to use inequalities. Minus 6 is less than or equal to, because we have closed bracket, y, which is less than 4. To prove that y is in the set minus 2i, we need to show that y equals minus 2x for some x in I. Now what I'm going to say is let x equal minus y divided by 2. And you're going to see why. Let x equal minus y over 2. Now I'm going to manipulate the inequality again by multiplying it by not minus 2 now. I'm going to multiply it by minus 1/2. Multiplying by minus 1/2 results, okay, we have a negative number we're multiplying it by, so the minus 6 is going to go to the other side, the 4 is going to go to the left side after we multiply it. So we're going to start with the right side because we want to write the left side. 4 multiplied by minus 1 over 2 is minus 2. And because we have a less than, we're going to keep that less than. And we're multiplying y by minus 1/2, so I'm going to say minus y over 2. And then I'm taking the minus 6, multiplying it by 1/2, that gives me 3. So it's less than or equal to 3. However, we said that x is equal to minus y over 2, so I'm going to substitute that in. So minus 2 is less than x, which is less than 3. And this is showing that x is in the interval I, because the interval I is this exactly. The interval I is minus 2 to 3, open bracket, close bracket, open bracket, close bracket. Okay? Because x is in I, and when we multiply this both sides by minus 2, we get y is equal to minus 2x. So we have y is equal to minus 2x. We can say that simply y is in minus 2i. Hence, minus 6 to 4, the interval, is a subset of minus 2i. Why can we say that this is a subset? Because we started with an arbitrary element in y, and we showed that everything here is also in minus 2i. So everything that's in this interval is also in minus 2i. And then we're just going to make a little conclusion here from the first and the second part. I'm going to say, therefore, because we have minus 6 to 4 being a subset of minus 2i, and minus 2i being a subset of minus 6 to 4, we conclude that they're equal, that minus 2i is equal to minus 6, 4, right? And this is what we're trying to prove, because if we go back to the top, we're trying to prove the answer to minus 2i. So that's it.